This is mainly a CB thing, but I have something for you hams too, so don't tune out yet. There's this idea among CB operators that excess coax cable should not be coiled. Now, this is wrong, and coiling some coax can even be beneficial. When you buy a CB antenna, you typically get about 18 feet of coax. Why 18 feet? So it's long enough to reach the CB rig. That is not some magical length that gives you a better SWR. Your SWR is determined by the match at the antenna feed point. So if you're using 50 ohm coax, but the antenna impedance is 100 ohms, you divide 100 by 50 and you have a 2-to-1 SWR. The length of the coax does not matter. But many CBers have been led to believe that the excess coax must not be coiled. So they've gone to great lengths to zigzag the excess coax through their vehicle, so it's never in a coil. Now, the antenna manufacturer should explain in the instructions that it's okay to coil the additional coax. And why that can be beneficial, I will explain shortly. Now, for you hams, I was watching a ham on YouTube do a review for a vertical antenna. Now, he was doing fine until he got to connecting the coax to the antenna. He said, make a few turns of coax into a coil to improve SWR. Now, as explained earlier, SWR is determined by the match between the coax and the antenna at the feed point. That cannot be changed by making a few turns of coax cable. Now, I can understand CBers being confused by all this. They don't have to pass an exam and be licensed. But hams should know better, especially if you're going to do reviews and post them on YouTube. And here's why some hams are apparently confused, thinking coil and coax can improve SWR. That's because your SWR meter can be confused. You're both confused, both the ham and the meter. Now here's why. Coiling coax creates a choke, which can block common mode current. What is common mode current? Common mode current is caused by skin effect. Skin effect. At radio frequencies, the current in a conductor flows only in the skin of the conductor. So you can think of coax cable as actually having 3 conductors. Now, how so? Well, there's the center conductor surrounded by the shield. That's conductor number 1. The inner part of the shield, conductor number 2, and the outer part of the shield, conductor number 3. Now consider this. At the antenna, conductors 2 and 3, the inner and outer shield are both connected to the same side of the antenna. Now, do you see a problem here? Now, some of the current from the inside of the shield can go down the outside of the shield. They're both connected together at the antenna. It's that current flowing down conductor number 3, the outer shield, that can fool your SWR meter into reading incorrectly. It's called common mode current. making several turns of coax cable at the feed point can block common mode current by creating an inductor. Now that's apparently why this ham mentioned earlier thought that coiling coax improves SWR. And it's also why coiling coax is actually a good thing. It can block common mode current. Now here's a qualifier. End-fed antennas actually use the shield of the coax to make up half of the antenna. But for dipole and vertical type antennas, you usually don't want the shield as part of the antenna. However, coiling coax really not the best way to prevent common mode current. Making a common mode choke using ferrite snap-on chokes or a ring is more effective. Now here are a couple of examples. You can either buy them like you saw there, or you can make one. They're not hard to make at all. So, don't worry about coiling coax. Coiling coax will not change your SWR, and use a common mode choke to avoid common mode current. So thanks for watching. Consider subscribing to this channel and 73.